I'm not sure in UK, but in Macau right now it's 7 p.m. Nice meeting you. Today I'm going to discuss regarding the tower data from the big data. I'm the associate professor in the Macau Polytech. I'm now in Macau. Although I'm in Macau, but you can find me practically everywhere because I'm kind of actively involved in the online. So you can find me on the Facebook or Google Scholar under the name of Amang Kim. You may just call me Amang because my Korean name Songyu is slightly hard to pronunciation. And then you can find me my research in the ResearchGate and then LinkedIn also. Why I'm saying this? Because my research area is kind of diverse. Right now I'm dealing with the data science, but also my one of my research area is blockchain governance game. And then they're dealing with developing the new network architecture by using the blockchain. And then the cybersecurity, biometric authentication, and then in the business economics, I'm dealing with the game theory, so-called stochastic game theory I'm also dealing with. So today's agenda is follows. First one, I'm going to discuss about the comparison between the big data and compact data. And then the next one is about examples of the compact data design. And then the third one is about the new data measure of the compactizing the data. And then the summary. So as you know, big data is relatively large scale volumes and multi-format data stream originated from the heterogeneous autonomous data sources. And then the big data is kind of inherited courses dimensionality. And then, yeah, as you know, data set size is beyond the availability of the database or the computation powers and software tools and so forth. And then the big data as that nowadays the majority of government and then the organization are interested into involving. And then additionally, big data has an attention to most of every industry with exclusively across the global seeking guidance for the best practices. But even global companies do not have much to show for their effort. There is a main reason why big data is not succeed because many companies are not ready to embrace the leveraging the big data from the improving the company performance, and then they do not know how to construct to compact data from the big data. And then it's noted that analyzing the impact of business rules does not require to have a massive processing or the stochastic modeling associated with the big data. The last one is quite important because many companies are believes that if they have a big data or a huge amount of data, they can improve the company. But practically speaking, that's not true. It has been quite a year. Most of the company, as I mentioned, most of every companies are involved in the big data, but not many of them got succeed. And then there's additional cases like 7-Eleven, for instance. They are not focused on the big data, but they have a quite good in shape, especially in the Japan, the 7-Eleven. The way of managing the data sometimes is way more important than just asking or just gathering the big data. So today, actually, it's kind of a conceptual idea, so-called the big data, compact data, because I try to separate as opponent of a big data. Usually, the opponent of the big is a small, right? But the compact data is not a small data. Okay, it's more likely the conceptual idea which kind of optimized data set, which give you the best asset without handling the complex data. And then the compact data should certain maximum knowledge of a pattern at the fine grind level effect. So it's kind of tailor-made data set in a certain way. And then particularly it will be quite important for the artificial intelligence because the design the proper compact data, especially for the vital, to developing the artificial intelligence or machine learning system, because that actually your data becomes your input, your major input of the artificial intelligence machine. Some of artificial intelligence machine is supposed to be the complex and then bring the complex idea or complex result. But some of artificial intelligence or machine learning model might be adapted even in the IoT. I will give you some example later on, but that's the idea why I'm start thinking about the compact data. So there are several ways of the compactizing the data. So first one is based on the network theory. So you kind of high dimensional unstructured big data into the low dimensional structured data. That's the way of compactizing the data. And then compression, reduce the size of data set as long as that data set is enough to show the majority of the value. That will be the fine. And then the data deduplication, so kind of removing the data redundancies. And then the data preprocessing, so give you the preprocess before you actually put the data into the machine directly. Now most of model design of artificial intelligence, they just rather put the real-time data, which is way big, and then sometimes it's a kind of confusion of the machine during the machine learning. So it would be better to suggest beforehand they kind of shape it up or clean up the data beforehand and then put the proper data set for the machine learning applications or machine learning system. So another one is a dimension reduction. That's another one, and then data mining, and then the machine learning models, which actually particularly which I'm interested in. So that will be the part of way of compactizing the data design. So I'd like to giving you some of example about the compactizing data. One application is machine learning based biometric security, which actually the idea is that by using the heartbeat, by using the ECG, myself and then my team members kind of developing the authentication system. So authentication system is basically the identify the people based on the heartbeat. And then I'm kind of propose, which is called the time slicing techniques. And then you need to understand the way of categorize or the way of identify the heartbeat conventionally is that they usually require to longer size of data because it have a lot of noise, and then try to extract certain features like a peak and then duration and then cycles and so forth. So they are extracting the certain values, kind of detecting of the signal. But that requires a problem to have a huge, not exactly huge, but relatively huge number of data. Like you need to take the ECG from the patient or from the people at least a couple of minutes, or longest like even couple of days they collect it. But of course, purpose is not about the authentication. It's more likely the detecting the heart disease. That's the purpose. But for the authentication purposes, still it requires to do a couple of minutes. And then the problem is that you may think about, collecting the ECG like a couple of minutes, it may not take long, but actually it depends on what kind of application you use it. For instance, you use the ECG authentication to enter the gate. Think about that. And then to measure the data, you take the couple of minutes. It's really long because compared to you tagging your ID or you tagging your fingerprint, it's just like a couple of seconds, right? So compare those kind of use cases, it will take quite long, couple of times more. But if you use this time slice technique, there are two ways of doing this time slice technique. It's just take the 15 to 30 seconds. Still it's slightly long, but it's a reasonable to customer or the to people can enter the building or the measure the ECG based on the smartwatch. This is quite reasonable, although the time or duration of collection of data is not that long compared to the conventional ECG collection. It's have a quite good result by using this technique. And then actually this technique by itself is already published on the paper. If you are interested, I will let you know later on. It's already published 2 papers with my colleagues, and then still looking for another one later on, but that's how it goes. There is another example, which is a detecting system. It's a totally different range of the area. It's part of civil engineering, and then in the civil engineering, they're looking for some of machine learning techniques for the detection of the defect of the material. So when you look at on your left side, usually they try to collecting the data for the around 1 to the 5 microsecond. Still there are a lot of data to shows up. So it's quite interesting because when I talk with the civil engineers, I mean, so another professors who I'm working on, he comments that only the this side on your right side is gonna be the part distinct whether that material have a defect or not. So instead of take a look at whole data, I just chunk it up for this part only, and then use that one as an input of the machine, training the machine to detect whether the defect there is a defect or not. So that also quite useful because the accuracy is not that. I mean, it's not like a 100%, but it's quite acceptable for the industrial standard in the civil engineering. And then currently, I'm done with my part, and then actually my colleagues who is in the civil engineering working on the contribution based related with this area also. And then the other one is like this is totally different one. It's not related with the artificial intelligence or machine learning, but you can think about as there's another subject of mine, which is a kind of developing the model, diffusion model for the pandemic. And then I'm kind of developing some of the important factors which never been explored before. And then that factors actually giving you the quite good shape of prediction. So this is basically a prediction model, as you can see in here. This is the formula of the prediction, which is not that bad. But this one is just conceptual. I cannot say it's really legitimate or it's really brilliant because it's not. I do testing with the sum of data, but it's not. I believe that's not enough to generalize this formula is good and then particular parameters which I claim is really valid. That is still need to be do the additional research on that. But for the first insight and then the data set that I use, which is data set like early this year in the Korea data, it's a quite good shape. Accuracy is prediction accuracy is not that bad. But again, this is just an idea. But main point is that you don't need, although you can get a huge amount of data, but you don't need to use all of them. I mean, that actually giving you the additional impact or additional harmful impact, because first, number one, it requires to the additional resources to computation and then database restoring the data. That's number one. Second, usually there is in terms of data scientists, they are very or statistician. They are very important to court, or they are very common court say that garbage in, garbage out. So if your data is not, the quality of data is not good enough, then although your model, your prediction model or your machine learning model is really good, but still your result is going to be the garbage. So that is a part of the idea underneath of this research. And then particularly the machine learning performance, I actually provide several measurement of the performance. Yeah, in the machine learning, there are many measurement is very common, like a confusion metrics and an accuracy, confusion metrics for the accuracies, and then the speed of the calculation or speed of the training based on the certain data set. But I'm kind of provide additional measurement factors. So actually, this measurement factor you can use it on your machine learning system during the training or during the evaluation. You can use them. This one actually coming from the quality engineering, which is another area. It's not like a computer science, but the more likely the industrial engineering or Six Sigma and so forth. So I'm kind of bring up the sum of these factors. And then these factors I actually introduced it for my previous research also. So you can take a look at in details how it works. And then I'm strongly recommend if for instance, you developing the certain machine learning system, either it's authentication or the classification, regulation, whichever you called it, you can use this measurement, how good it is, how your system is good, how the performance is good. You can give that an idea to or persuade to your reviewer based on this kind of a measurement. So I'll skip it for details for regarding this measurement because that is not the part. I mean, the explanation about this measurement is not the part of the research in here. And then the other idea which I'm still looking for is that so-called mode-based standardization. I believe that if you are in the statistics, you know about how to get the so-called normalization, right? So it's a typical SSG, and then you know that how your variances change, and then your normalization based on the mean, and then this is a condition. Once the number of samples is bigger than the sample means becomes the means of the mother set, and then the standard deviation is also follow the samples of standard deviation will be followed the standard deviation of the mother set, right? That is very commonly used in the statistics to get the measures and so forth. But frankly speaking, I believe the mode is which is the highest probability to get an action. That will be the more proper, especially if you design the engineering system, because sometimes mean doesn't give nothing. For example, like if you flipping the coin, for instance, if you flipping the coin, the average of the flipping the coin is half, right? It's like the 0.5. But in the real world, it's not. There is no 0.5 in the coin. There is either you toss the head, which is 1, you toss the tail, it's 0. So either 1 or 0. There is no 0.5 in the real world, actual event. So similarly, if you're dealing with the machine learning system, you'd better take a look at what will be the highest probability, which is basically mode, and then you kind of decompose it or compose it to some sort of normalization based on the mode, not based on the average. I mean, as you know, most of a probability distribution, almost the mean is the same as a mode. I mean, that's like a Gaussian or the exponential. Most of well-known probability distribution, the mean is the same as a mode, but not the general distribution or not the distribution coming from the practical measurement, practical data set. It's not always true. So that's why I give you some idea to how to normalize them. So how to get the W, which is equivalent with the Z, and then the sigma, which is equivalent with the sigma in here and so forth. So you can have some formulas for that. This one is kind of theory, but actually this is the first time I introduced in this paper. But next time, if I developing the machine learning system, I'd rather go with try to use this formula, which might give you the better performance of the system. So as a summary, compact data set is contained the maximized knowledge patterns in the fine ground level of effective and personalized utilization of a big data system without the big data. That's the whole point. So instead of handling the big data by itself, you rather going with the more compact data would be the better for your, not only for the system by itself, also for the performance wise would be the better. And then it's kind of a tailor-made design. So which actually is it looks simple, but actually it's not a simple because it depends on the what kind of data you're dealing with. So you should understand the nature of data first, and then you should understand the system first before you doing or you using the data by itself, or you make a tailor-made compactizing the data. Doing before that, you should well know about the data by itself. It's coming from the business or consumer, or is coming from the internet traffic, or is it coming from the biometric human data? Yeah, all of data set have a different characteristics, and then if you don't know the characteristics of data by itself, you cannot compactizing the data. That is a bottom line. So you should well know about your subject first before you compactizing the data. And then last be that compact data can be even more suitable, especially if you want to develop the engines in the IoT devices, like you making the machine learning authentication system on the smartwatch, for instance. So that kind of cases, you cannot have a big data to handle on the IoT devices or like a small performance devices. You cannot do that. So you should somehow compactizing the data before you put that data into the IoT devices. So I think that's about it.